Hi everyone, I'm Tianfang. I am part of the FH7 Senior Design Group along with Ben, Cord, and Jackson. We are advised by Professor Mattan Erez, and our project is the Computer Architecture Explorer. And today I'm going to give a tutorial on how to use this website. So let's get started. So I have a couple simulations set up here, and when you first think about the performance of a processor, of course you think about the IPC. So let's take a look at that. I'm going to go here and pick processor, and the IPC is already picked. And let's get the simulation first. I want to think about, does, as I'm increasing L1, the size of the L1 cache, does that, how does that affect the IPC? So let's get this simulation and let's add this metric here on the graph. And so we can see, it does increase a little bit as you increase the L1 D cache size, but maybe not as much as we'd hope. So, what are some other things we can look at? How about the L2 cache size? Now, if I get this simulation, looks a lot better. So, as you can see, the size of the L2 has a relatively much larger impact on the IPC than the size of the L1. Very interesting. Let's take a look at something else. How about cache hit and miss rates are very important. So how about we take a look at that? Well, we're more interested in the miss rates, really. And so, I'm going to do something obvious here as we increase the size of the L1D cache. You would expect that the hit rate would decrease, which is obvious. But something that's maybe not so obvious is, let's take a look at L2 and the miss rate. By the way, if you want to add, or if you want to delete one of these plots, you just click down here and it'll delete it. Whoops, I deleted the wrong one. Let me add this back. Alright, so let's see. This is a little unexpected. The L2 miss rate is increasing as we're increasing the L1 D cache size. Now, how does that affect? How does an increase in the L1 size affect L2? Well, let's think about it more closely. As you are increasing the L1 size, you are going to be storing more data in the L1 cache, and kind of trivially, the L1 hit rate will increase and the miss rate will decrease, and that's what we see in the graph. But an unintended consequence of this is that the data in the L2 cache that was supposed to be accessed when you miss the L1 is now being accessed less often because you're missing the L1 less often, and this is causing the more recent data in the L1 to the more recent data in the L2 to get evicted too early, sort of. Relatively speaking, earlier than if the L1 was smaller. And so now when you eventually you're going to miss on the L1 and go to the L2. Now that data is that potential data is less likely to be in the L2 because of this relatively higher eviction rate. And so consequently, the L2 will have a higher miss rate as you're increasing the L1 cache size. So, these types of perhaps somewhat unexpected interactions between various parameters of a microarchitecture is exactly what we want you guys to sort of explore and discover for yourselves as you are using this tool, and hopefully that will help in your understanding of computer architecture as you go through your classes, and maybe just to study on your own time. And so yeah, uh, that concludes the tutorial. Hopefully you guys have fun with this tool, and thank you.